Hello there, this is Laksh Sharma, uh, and I'll be performing my second task for the Sparks Foundation GRIP Rotational Internship Program in Data Analytics, and that's going to be from the given iris dataset, predict the optimum number of clusters and represent it visually. Okay, so as part of our usual procedure, we're going to be importing the modules, and then we see the dataset so that we can, see that it's imported successfully. Moving on, we find out if the data has any null values, and it doesn't because it says false. Then we're going to use SNS to plot the values that are obtained from this. Okay, so as you can see, the petal length, the sepal width, and the petal length in centimeters and petal width in centimeters. So these are the factors that we are going to plot for the three species that we have in the data. Moving on, as you can see that we have the plots ready with the values over here on the left, different types of plots. Then what we can do what we're going to do is we're going to find the optimal number of clusters using the elbow method. So what is an elbow method and why do we need it to find clusters? Okay, so an elbow method, the elbow method finds the optimum number of data point clusters for a data set, because if we go in blindly, we might have like 11 data clusters, which might not correspond to a very good understanding. So we need the minimum amount of points that represent the data in form of groups, and that can be found using this method. It's called the elbow knee method, by the way, because it looks like an elbow knee. So as we can see from the elbow knee method using this code, that the range lies somewhere between 2 and 4, because according to this method, you have to take the points between this knee points. So we will take 3, okay. And then we just find the clusters. You see, n clusters is equal to 3. We do the machine learning part. The arrays are there. And then we plot the graphs. And with the centroid, we can see, okay, these are the centroids. After that, we fit the models and we find the clusters. Cool. So one of the things that I really would like to add here is, this is one of the things that I think it's very cool to use it as. Like the centroids can be used to find certain data points that correspond to a certain value. For example, if it's like 5.5 and 20 here, so we can just, according to our, like this can be one species, this whole entire can be one species, this can be another species of the same genus. You understand, like different variations in the same genus. So yeah, I think this is a very good way of doing it and representing data and having fun with it. Thank you.